Let's do a couple more examples of calculating probabilities of sequences. So here we have a screenshot from a different video game. You are being shot repeatedly by this guy, Triggerman. His name is in red because red is bad, as we all know from, well, most video games these days and Star Wars back in the day. Your health is getting pretty low and your dog is mad, so you should probably attack him back. And the way this game works is you can choose a part of the body to attack, and they all have different percentage chances to hit. It's not really clear in the games a lot of the time if that matters, but it's nice to give people options. So let's pretend in this game you get to attack 5 times. He'll still be shooting you while you do it, but that's the way the game's set up. So we could just do various sequences here, like you hit the torso all 5 times, so the sequence would be T, 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 if you abbreviate T for torso. And then you can calculate the probability of that. So we can see from the screenshot that it's 81, which in this game I assume means 81%, not $81, because that wouldn't be a thing. But 81% chance to hit. So if it's 5 times in a row, you just multiply the probabilities. That's how it always works with sequences. And you get the probability you'd hit all 5 times is only 34.9%. So that's not very likely at all, which means, your probability of hitting is very good, but 5 times in a row is not all that likely. But then if you miss all 5 times, so the probability of a miss, if I can spell torso, well, if it's 81% chance to hit, there are only 2 outcomes here. You either hit or you miss. So the probability of missing is 1 minus 0.81, which gives you 19%. There are a lot of situations in probability where there are only 2 outcomes. Something either happens or it doesn't happen. Those are called complements of each other if you want to get technical. Well, the word can be used for more things, but that's what you can call it in this case. But they add up to 100%, so to find the probability of the other one, you just subtract it from 100. So, well, subtract it from 100% or 1. Whenever you're dealing with the calculations, you actually need to work with decimals. So the probability of missing all 5 times, you could do 0.19, 0.19, 0.19. But of course, if you want to do that a little shorter, just do 0.19 to the 5th. So I've already formatted this as a percentage, so you can see it's only 0.025%, which is very, very unlikely. So it's not super likely you'd hit all 5 times, but it's really unlikely you'd miss all 5 times. So, what's really going to happen, there's a lot of probabilities in the middle that we'll look at some other point. But of course, you can aim for this guy's arm instead, which is a little bit lower probability. If you hit his arm, there's supposed to be like a thing where he can't shoot you anymore, but it doesn't seem to matter. I don't know, whatever. Games aren't realistic. But so the sequence here, you could abbreviate it A for arm 5 times. And then the probability of that, this one was 77%, so you just do 0.77 to the 5th would give you that probability of 27.1%. So even less likely than the torso. Our last sequence here, let's suppose you mix it up. You want to hit this guy in the torso, the arm, the leg, and the other leg because, it's a game. Why not try different things? So the sequence here, you might write this as TAALL. And here both arms and both legs, it really doesn't matter. It's 77 for both arms, 86 for both legs, so it doesn't really matter which one you're talking about. We don't need to distinguish right leg and left leg in this case. So the probability of that sequence would be multiply the probabilities 0.81, 0.77, 0.77, 0.86, 0.86. Boy, that is, no, that's obvious. Obviously, if you get something like 3,500%, something is wrong with your formula. And in this case, I typed some extra decimals and it corrected it to something I didn't want. So let's make sure that works. So 35.5%. But really, you could do sequences of events with anything. You could do it with coin flips. This is more like a typical math class problem dealing with fair coins. So if you flip a fair coin 4 times, the probability you get all heads, well, that's just the sequence HHHH, where I'm using H as an abbreviation for the coin comes up heads. And then it'd be on the 1st, 2nd, 3rd, and 4th try. So if you calculate the probability of that, it's the same idea again. The probability of heads is 0.5, so you just multiply 0.5, 0.5, 0.5, 0.5. You get 0.0625. All tails, well, unsurprisingly, If the probability of heads and tails are the same, then the probability of this is going to be also 0.5 times 0.5, or whatever, 0.5 to the fourth power, also 0.0625. And that's the thing about coin flips, as opposed to like a lot of other situations, is really any sequence of 4 flips, all of these are going to have the same probability because every one of these sequences is 0.5 times 0.5 times 0.5 times 0.5. So each one of these is 0.5 to the fourth. I don't even need to type it in every time. It's just going to work out that way. And you could list all the sequences if you wanted to. The number of sequences you could get, possible 4 flip sequences, the number of possible sequences there are is, well, there are 2 choices for the first one, heads or tails, 2 choices for the second one, 2 choices for the third, 2 choices for the fourth. So there's 16 possible sequences of 4 flips where each flip is either a heads or a tails. And each one of them, unsurprisingly, will have probability of 1/16. A lot of situations are a little different when you start, like we looked at in class, like with rolling dice and doing more complicated situations. But if you're ever dealing with coin flips, the probabilities work out pretty simply in that case.